All right, so we're going to learn about this integration technique called partial fraction. And it's a technique that you might be tempted to complain that it is too difficult, but I want to show you the world before this technique was developed. And the way that, for example, this harmless looking integral, the way that people would have solved this before partial fraction integration technique was developed is brutal. Look at how long that is. And it's actually using a technique that you probably already know. It's trig substitution, which uses a triangle. And you may be thinking that, wait, that's one of the nicer squares. Like I can factor this and I can say that this expression equals 2x minus 3 times x minus 2. So it's 1 over that. But then what? How do you take that integral? 1 over dx, and then what? Nothing happens. So you need to first complete the square. And I wrote that if you're interested. It's a great practice. So follow this. Once you rewrite this integral like this, then you go, oh, there's somebody being squared. That's the somebody that's being squared. And then there's another somebody that's being subtracted from that somebody. And that has to equal a third side squared, which has to be height squared. Oh my goodness, that's Pythagorean theorem going on there. I think there's a triangle. And this has to be the hypotenuse because minus follows that. So you spot that, you label the side of the triangle correctly, which is the most important part of trig substitution. You go through that. You can stop here. I went ahead and simplified it so I could show you that you get the same answer, obviously, but using partial fraction and partial fraction decomposition technique, you get the same answer in one line. You see? You get this, and then boom, done. Very easy. So you take integral of that. This is your u. So that is your answer. So thank you, Bernoulli, for partial fraction decomposition technique, but also for creating Euler, one of the great mathematicians. So we're going to learn this technique because there is a technique, right? Because how do you jump from this to that? You probably don't have any problem saying that, yeah, I mean, the factor, if I factored this, it would be x minus 3, x minus 1. And if you multiplied it through, you would get this back. So this and that, it's the same thing, same exact thing. So I can write that 1 over that equals to 1 over the same thing, but factored. Okay, that's fine. If there was a product there, that's fine. But if I put plus sign there, that's not fine, right? You don't like addition, multiplication, tomato, like that's not the same, right? Because that would be, let's think about this and you will really see why you can't do that. Okay, if you had 1 over 6 and it equals to 1 over 3 times 2, okay, you probably agree with that. And then that's same as just split into 2 fractions. If you had a dot like product there, that's fine. But if I put plus, you would hate that, right? Because that does not equal to 1 over 6. That is 5 over 6. Because if you found the common denominator, which is 6, you would have to multiply this by 2, this by 2, this by 3, this by 3. 2 plus 3, it's 5. Can I make it equal to 1? And if I can, then that is the whole essence of partial fraction decomposition. And I could by playing around, okay? How did I get 5, first of all? I got 5 by 2 plus 3. If only I get minus 2 plus 3, I would get 1. How can I make that happen? Where did I get that 2 from? That 2 came from there. Well, if I had minus 1 there, then when I do all of that, I would get minus 2 plus 3, and I would go 1 over 6. That works out. So you can actually say that 1 over 6 equals to minus 1 over 3 plus 1 over 2, because that gives you 1 over 6 back. That's legal. That's allowed. That's exactly what you're going to do here. So this is what we're going to do in this case. So we're going to find the common denominator, and common denominator for these is just a product. X minus 3 times x minus 2, okay? So you multiply this by x minus 2 and the top by x minus 2. Okay, so that is x minus 2. And then this fraction needs x minus 3 because it doesn't have that. It only has x minus 2. And then you put x minus 3 there. Now that does not add up to 1. That adds up to 2x minus 5, right? 2x and minus 5. That does not equal to 1. This certainly equals to this, but then that 1 has to be the same here. Can I make it be 1? And I can somehow, because I can think of, oh, if I had minus in front of 1x, and then that would be positive though, because it would go in front of the whole thing. X's would get canceled, but that would give me minus 1 in the denominator. That doesn't work. Maybe I could have minus here. That does work. X plus 3. And x's get canceled, and you get positive 1 here. That's partial fraction decomposition. Finding what type of a coefficient will give you 1 back, so that you can say this equals this. But does that equal to denominator? Does denominator equal to 1? Because that has to be the case. And if it is, then all is well. So you can kind of make that happen by thinking about like numbers like that, trying things out. However, there's a rule that you can follow. This works, and if you forget the rule for the simpler problems, you can actually use this rule for a lot of problems. But when things get complicated, and they do, you want to have something to follow that will give you right answers every time. It is this technique, okay? So we agree that up until here we agree. And if I put a multiplication there, everything is fine. But if I want to put plus there, then I can't say that this is 1 and this is 1. I can't, because this actually happens to be negative 1. We already figured it out. So maybe I can say question mark and question mark. I don't know what those would be. That's fair. But I can also say A and B. A and B are going to stand for a number, right? These are coefficients. So it can be 5, it can be 7, I don't know. And it can be that they have the same coefficient, but you don't know that yet. So if I wrote that, then everything looks fair. Well, I still need to find A and B, and that becomes your task. So if I wanted to put the two fractions together, I would find the common denominator, which is the product. This fraction, or A, is lacking x minus 2. You multiply A by what it's lacking, and B by what it's lacking, and that is x minus 3, okay? And we understand that this expression is exact same as this, so the denominators are the same. The problem is that numerator has to be 1. So let me focus on that. Let me not rewrite the denominator, which I know to be the same, and only worry about the top part, the numerator part. Now, how do I find A and B? There are two variables that I'm after, one relationship. And this is kind of playing around that we did at this step. That step was beneficial. It's a good mental exercise, but you do a similar thing here, what we did at this step. You try to eliminate this term, and then you worry about P, and then you try to eliminate this term, and you worry about finding A. How do you do that? If you could make x minus 3 become 0, then B would be multiplied by 0, that would make this whole term go away. How can I make x minus 3 be 0? If x was 3, and x takes on any real number, so I could set it to x equals to 3. Then I put 3 instead of x everywhere. For just a minute, x is going to be 3. There we go. 0. b times 0, 0. So then I only have to worry about that. 1 equals 3 minus 2, that's 1. A times 1. Oh, so a is 1. Okay, you have that. So now eliminate this part of the expression. How do we do that? By setting x minus 2 to 0. What value of x will accomplish that? If x was 2, that is 0. So I only have to worry about 1 equals 2b times minus 1. Looks like b is a minus 1, okay? So a is 1, b is minus 1. This is how you find the coefficients. A is 1 and b is minus 1. Okay? Then you can rewrite this integral like so, and then you can solve it, because like this is u, and then du is dx. So you can just treat this as x, and then this is ln, right? Because 1 over x, integral of 1 over x dx is ln x. So that's what you get there. And that's it. So you want to kind of factor this expression, and then try to write it like, multiplication, that's fine, but then addition, and then you don't know what the coefficients are. So put a and b there, and then you'll see. It does get harder than this, but that will be covered in the next video. So hopefully this was helpful, and hopefully you saw how much harder this could be. So it's definitely a very practical trick. It's something that somebody was like just sick and tired of using this way and was like, there's gotta be a better way. Thank you so much for watching. Bye.